Hey guys, today we're back with this 110 volt DC power supply from the two Ego batteries in series, and I have already put the battery control module and the breaker in. And if you don't know what this is, in the previous video we actually talked a little bit about how some tools with universal motors can run off of AC and DC, and things like light bulbs and halogen lamps or just a regular heating element, things of that nature can definitely work off of DC well. And I showed several tools run off of this fine, including the shop-vac. And at the end of that video I mentioned if you would like to see me go further with it, I would add a low voltage cutout, which I totally recommend on something like this. And I would add for some circuit protection, which I definitely recommend as well. So with this little prototype box I started with, I was very surprised because it's something I just had and it would work for prototyping, but it actually worked out to keep going with it, at least for a little while. You'll see some of this later of me putting these components in, but I wanted to get right into the detail of it so you know what the video is about. But so as we see some of the tools up here that we ran on it before in the first video, it's pretty handy to have, so it might be worth spending a little time, a little bit of money, and making something a little more appropriate for it. We have it where it just plugs in to the batteries, which that's the same as before, but now we have our breaker and we have our voltage cutout. This will go from 10 to 60 volts. So as you'll see in the video, I just had this going across one of the batteries, and when I flip it on, it gives me that battery level. And I've actually pulled this pack down. I've been using it to do some sanding. I've done it running the shop-vac a little bit, and I'm trying to get this battery pack a little bit lower so I could show at least how initially I'm going to set up my set point. So of course I'm basically just using it for low battery cutout, but we have a S1 setting which will be the charge enable. So you could have the load hooked to this as well as a charge input to this as well as the battery output. So we're just doing the battery in and then the output, which is in series, putting it through to my receptacle here. So this only lets me know one battery. So I'm only using light batteries with light charges, and I'm going to stop this. I'm going to do 53 volts for the demonstration just because I want it to cut off. If I can make it cut off, I want to show you how it'll work. Typically, I'll try to have the settings on here. I'm going to try to set it initially for like 50 volts or 48 volts, something like that. That way, if you're using it and you're not paying attention, even though you've got a nice display to see, if it does pull down to that 50 volts, 48 volts, whatever you choose to set it at, it won't let you go much below 100 volts on your tool, and it definitely won't let your batteries deplete because you don't want to go below around 40 volts. 40 volts is safe on these, but we don't even want to get down to say 80 volts. So to protect the battery, protect what we're using, you know, just making sure the current doesn't go too high because of a voltage drop. Things like light bulbs, you know, incandescent light bulbs, halogen bulbs, it would not matter. A heating element, something like that, it would just have a little bit less wattage. It wouldn't affect it at all adversely. So we see we have like a charge 2 setting where it would disconnect from the battery. And then we have a cut off where it cuts the load off. And it's really just a relay that's going back and forth. Am I going to the load or am I charging? So if we hook this up per diagram, we're going to have our battery input power coming in plus and minus here on the top. Our load or output will be here on the next two, minus and plus. We can see the minus is simply tied together here, or the negative contact is just tied together. So we do have to have the monitor in. We probably don't have to do the minus back out, so that's a good thing. But we are switching our positive on this relay contact between what's coming in and either going to the output or the load or going to the charger. So that's why our S1 and S2 will select our upper and our lower limit. So we'll wire it up and we'll give it a try. Okay, so back now, this is how I decided to wire it up with the two batteries. And there's a lot of ways you can wire it up. The reason I decided to go this way, I'm just going to monitor one battery. So I'm allowing my circuit breaker to interrupt so I can tell when I have my power on, because my voltage meter will light up. So I really like that. And then if everything's working okay and my battery voltage is high enough, it's going to allow my plus from B2 to connect to my minus to B1 and give me my full DC voltage out. And for me, if I ever need to jump this one out and just run one battery, well, I've marked that B2 is my monitor side. And I have all my leads, of course, marked as B1, B2. I just always keep a wire labeler I've had for years with CNC upgrades and stuff I used to do. So I have just stuck some wires on here just to temporarily test it. Wired up as shown here. So we just got our plus and our minus battery monitoring. And then our output from our plus from the relay, I just called it out. Going back to our B1 negative, just as shown. So let's see what it does. And there we go, 57.8 volts. And we should be getting our output. And there we go. So I'm actually going to put all this back together now, and we'll see how it does. We're 56.5 volts across battery 2 that we're monitoring. And if I bring a meter over, on DC volts, of course, which is odd when you plug into a outlet, but we see we're not getting any voltage. And we know we're on, and we should be getting voltage, but I do know I brought this up to 56.8, so it's actually thinking it's in charge mode until it hits 56.8. So what we have to do is just hold this down, and we're just going to bring this down. You heard it click maybe, but we're going to do like 56, and that'll take. It'll just be decrease and increase. And then after it goes back steady, if we press S2, we'll be setting S2, which is our cutout. So now that we got 56.5 on the battery monitoring, it has to be above 56 volts or to try to charge, so it'll protect that way. But we got 112 volts out right now, even though these batteries are pulled down some. So we pulled down to right at 53.8, but it wasn't enough to trigger the low cutout. So instead of getting a heavier load, I'll just adjust this to show you. If we wanted to make this cutout, say at 54.5 volts, we want to cut out, and we'll let that take. So now at 56.4 on the battery, we have a charge of 56 volts. And we have a discharge cutout at 54.5. So let's see how that works for us. And there we go. It cut out on its own. Come back. There we go. Cut out on its own. And what it'll do is it'll stay cut out unless this eases back up to 56 volts, like it thinks it charged to that level, and then it'll let it come back on. So it's right at that point. I heard it click then. So there we go. That's a really, really easy way. And it's a cheap way just to protect your batteries from being low voltage. You know, I see stuff all the time asking about low voltage cutout. And there's another module that I like to use as well, but it don't have the same panel mount and the membrane. It's just an open frame, an open board controller. I'll have a link to both in the description in case you're interested. I did actually consider buying 2 of those or 2 of these and having a bigger box. You're just going to get more and more bulky, so you got to be careful. You got to weigh your options, you know. But if you had room to put 2 of these in, you could actually monitor both batteries and go in series if that's what you wanted to do. But I really like this little protector. I mean, for the money, and it goes up to 60 volts. You could, like I say, you could definitely do 2. I think it's fine to use 1 since I have such a big margin of error on my shutdown because I'm not going to go below 48, 50 volts. So with decent batteries, if you got them charged the same, There's no way you'll pull one below 40 volts without the other if they're good batteries. So I work on mine, as many of y'all know. So if I have one that bad, it needs working on anyway, but that's my opinion. I really wouldn't want to go any wider or taller, but maybe a deeper box. I barely scrape by on the depth. But as mentioned in the first video, there's so many different ways to do your contacts to your batteries. And I just showed one of the more economical and pretty easy way to do your contacts to your batteries, especially for a prototype or your first trial, trying to keep the budget low on projects. But many of y'all know in my channel, I also use things like the chargers that I have many of. I use the contacts off the chargers because your 4 pins come off and you really only need the 2, but of course, that's really great blade contact. But one thing I wanted to point out, a viewer and a fellow YouTuber named Jacob Quarter mentioned that at jacksmallengine.com, you could get the snowblower battery bay for like $40. And I just commented back to him, that's a really great idea. Now, I'm a Georgia boy, so in the South, I don't even think about snowblowers that much. Don't really see them, but that's really a good idea that I didn't even think about. So if you're interested in that, check it out. And also check out his channel because he does a really lot of neat stuff with Ego as well, including his own remote control Ego mower. So if you get a minute, make sure to check him out and subscribe to his channel if you'd like to do so. So I just wanted to share a little bit of update on this and just taking this to the next level and see if it helps anybody else. So why am I out here at the edge of the woods sanding my wooden frame? Well, first of all, because I can. And if you found this video today being helpful, please like, share, subscribe, and thanks for watching.